Okay, guys, we're going to talk about deductive reasoning today, which is lesson 2.3. Now, earlier this year, we talked about inductive reasoning, which is based on observing something and making a conjecture about it. Well, deductive reasoning is logical reasoning. I kind of like to think of Spock on Star Trek when I think of this. Reasoning logically from given statements to a conclusion. So true statements would give you a true conclusion. So here's an example right here of deductive reasoning. The catalog states that all entering freshmen must take a mathematics placement test. You are an entering freshman. Well, the conclusion I'm going to make from that is that you will have to take a mathematics placement test. And what this is called in geometry is called the law of detachment. Let me scroll down. And the way you'll see it is if P, then Q is true. If that is true, then P is true, and then Q is also true. P implies Q. So here's an example of the law of detachment. If 3 points are collinear, then the points are all on one line. E, F, and G are collinear. So you can conclude that E, F, and G are all on one line. Here's another example. If I find $20 in the street, then I'll take you to the movies. On October 10th, I found $20 in the street. So the conclusion would be is that I would take you to the movies. Hopefully the reverse of this happens and you can take me to the movies because I want to see this movie, except it's in November, just to let you know about that. Now, does this example follow the law of detachment? Here's your given. If it is snowing, then the temperature is less than or equal to 32 degrees Fahrenheit. The temperature is 20 degrees Fahrenheit. You conclude it must be snowing. Your conditional and its conclusion are both true, but you cannot apply the law of detachment and conclude the hypothesis is true. You cannot come to any conclusion about whether or not it's snowing from this given information. So there's no snow. Now the next thing we're going to talk about is the law of syllogism. If P then Q and if Q then R is true, then if P then R is true. So we're going to use the law of syllogism to draw a conclusion from the following true statements. If a number is prime, then it does not have repeated factors. If a number does not have repeated factors, then it is not a perfect square. So you've got two true conditionals where the conclusion of one is the hypothesis of the other. So, if a number is prime, then it is not a perfect square. That's using the law of syllogism. And just for fun, I put this down here for you. You can give me the answer tomorrow as we practice some of these in class.